when I started looking into Effect, I started seeing, well, this has a lot of promise and potential if you use it in the right way. And what I mean by that is like, you don't have to necessarily go from 0% to 100% overnight. You don't have to completely redesign the entire application to take advantage of some of the benefits that Effect has to offer. That's kind of how I started, was incrementally adopting Effect in parts of the code base. And this was really what enabled it to work.
Welcome to Cause and Effect, a podcast about the TypeScript library and ecosystem called Effect, helping engineers to build production-ready software. I'm your host, Johannes Schickling, and I've been building with Effect for over 4 years. With this podcast, I want to help others understand the powers and benefits of using Effect. In this episode, I'm talking to David Golightly, who's a staff engineer at MasterClass. In this conversation, we explore how David has built Cortex, MasterClass's AI voice chat system, leveraging Effect streams heavily to build a cutting-edge AI experience. Let's get into it. Hey, David. So great to have you on the podcast. How are you doing?
Doing great. Thanks for having me.
I'm really excited. The two of us had the pleasure to now meet in person twice in the course of the last half a year. The first time we've met in person was at the Effect TypeScript meetup in San Francisco. And then a couple of weeks ago, we had the pleasure to meet again in beautiful Italy, in Livorno, where you've also given a talk about Cortex and what you're building at MasterClass. And it was such a pleasure to spend a bunch of time together and talk about all things TypeScript related beyond. You also have some beautiful music gear in the background. But today we're going to talk about how you're using Effect at MasterClass. So would you mind introducing yourself and sharing your background?
Yeah, sure. My name is David Golightly. I am a staff engineer at MasterClass, and I've been in the industry building mostly web applications for about almost 18 years now. I've also dabbled in some mobile applications, some back-end, some other embedded applications over the years. But my main focus has been first in the JavaScript world and then more recently in the TypeScript world for the last several years. My actual background, though, I don't have a computer science degree. My education is in music, and I grew up surrounded by pianos. My father is a piano technician and also a piano professor who plays classical, everything you could think of classical music. He's played it. He's played with orchestras, and he's, played solo concerts and chamber music and so forth. So just steeped in classical music growing up in pianos and also in repairing pianos, which I found somehow translated into programming, sort of. You're doing a lot of really repetitive tasks. You have 88 keys. You have 230 some strings on a regular piano. So there's a lot of repetitive tasks, and you quickly figure out ways to work more efficiently when you're doing piano repair. So later on, after I got my degree in music, I found that it wasn't, music is a passion of mine and it's something that I still do. It's not something I want to try to make a career in. And so I quickly discovered that, programming is just right there, and I actually enjoy doing it somewhat. And so I devoted some energy into learning how to do that professionally. And, all these years later, here I am.
That is awesome. And such a funny parallel, since we never talked about this, but my mother also happens to be a professor in piano. And so I likewise also grew up surrounded by pianos and played the piano for quite a while, but then also found myself more attracted to technology. But I think this is a fairly common overlap of people who had their start in music or a different kind of art, and then gravitated also towards programming. And I think it's just a certain way of like how someone's brain works that really there's a couple of people come to mind who have professional music backgrounds who are just like absolutely brilliant in the engineering field. So that's a very funny parallel. But keeping it a bit more focused on like Effect, what has brought you to Effect? How did you first learn about it, and what did you think about it when you saw it the first time?
Yeah, so I was not necessarily going to adopt Effect for the work I was doing, say, maybe over a year ago, which was more React focused. It wasn't something that I was necessarily considering. I think React is a great framework, and it totally transformed how we do front-end development. But it's not without its problems in terms of state management and so forth. But I was mostly happy with it for the front end, and we try to keep things lightweight there. But then I got asked to work on this new project, Cortex, which I'll talk about a little bit more. And that was going to be a server-side application that was also not a conventional API server. Instead, it was managing a lot of async events, a lot of open WebSockets, more than one, like several open WebSocket connections that it needed to then coordinate. So I was looking at a proof of concept that somebody else at our company had built that was really, what we call async hell. That is just lots of callbacks, lots of event listeners, passing around references to random things. And we're starting to try to build into it observability and error handling and, more advanced interruption type features that involve coordinating the state of multiple WebSockets. And it just wasn't going to work. It was not going to scale. The implementation was just going to get increasingly tangled. And so that's when I started looking around for, what is the state of the art here? I had used RxJS in the past, and I think that, for people who've used RxJS, when they see Effect, that's what their first thought is. Oh, this is RxJS. I've seen this before. This is familiar to me. It's just another RxJS kind of knockoff. I didn't really find it to be the case, though, for several reasons. But I think that what really caught my eye with Effect was the really active community. Because when I'm looking to adopt a new framework that is going to form the backbone of how we build an application, I don't want to have to be inventing stuff whole cloth. I don't want to have to resurrect things from a couple of examples that don't really apply to my application. I don't want to be in the dark and be on my own. And I especially don't want to ask my teammates to accept a framework where they don't have the proper documentation or the guidance. They don't know where to find help. And so really, I found that the community seems to be Effect's biggest asset, and just how helpful everybody is and how enthusiastic everybody is really eased the adoption process.
That is awesome to hear. And that definitely also reflects my own perspective and my own reality. This is what drew me to Effect very early on. The community was much smaller at this point, and I tried to play a positive role in growing and forming that community. But it's also something I'm super excited about and super proud of, that we together, brought Effect to the point where it is today. And it attracts more brilliant minds. And it's also interesting that Effect attracts a lot of experienced engineers like yourself, but also new engineers that are drawn to building something great. And that community is such a compelling aspect of that as well. So maybe to linger on the RxJS part for a little bit, since quite a few people are kind of comparing Effect with RxJS. For folks who are familiar with RxJS but not yet with Effect, where would you say there are parallels and the commonalities, and where would you say things are much more different?
Well, in RxJS, the idea is it's very stream oriented. So you essentially are creating everything is an observable. It can emit events. And this is really useful. Actually, I think a lot of programming situations can be modeled in this way. You have, especially asynchronous stuff, really anything side effecty is happening asynchronously. You can't necessarily expect it or predict it, but then you have to react to it and do something in response to it. You have user input, user loads the web page. You didn't know when or why they were going to do that. They click on a link, or they decide to watch a video or fill out a form or what have you. This is, ultimately the timing and coordination of these inputs are driven by humans. And likewise, when you have systems where you have, connections coming from third-party services, or you have other kinds of asynchronous behaviors where you have to do, connect users to each other. A lot of the hardest parts of programming happen when we have asynchronous behavior that we have to model. And this is why, I think you look at paradigms like HTTP or, more specifically, like the model view controller that you see in Rails that is still so successful. And one of the things that has largely done is allow us to architect applications around kind of one-shot actions where, you get essentially a function call via an HTTP request, and your application now has to implement the function call and respond with it. But it's everything that happens between the request and the response is largely, typically serialized. It's sequential. It's not in parallel, right? Which is great. It makes things a lot more easy to reason about. Things happen in a sequence A, B, C, D, E, and then you're done. But most of what we have to deal with, especially in building web interfaces or building applications like Cortex, is not like that. Because you have a lot of things that can happen, and you might be in the middle of one thing and then something else happens that you didn't expect. And now you have to deal with that. And a lot of this also involves kind of keeping state updates going. This is why React superseded jQuery, because they're really good at this. But getting back to your question about RxJS is kind of an even more next level approach at this, where you can model everything as an observable. You don't know when it's going to happen, but you know that you might receive one or more different kind of events. And then how do you combine events from one observable with events from another observable when they need to interact to produce some sort of output? And RxJS is really built around this sort of model. The thing is, though, RxJS is also like trying to be not just RxJS, but it's a reactive framework that is cross-platform. So you have the same APIs, more or less, that are designed for JavaScript or TypeScript that are then also ported over to Java or ported over to Swift or ported over to Kotlin or ported over to whatever other language or framework. And so I think there was an intentional desire on the part of the designers there to keep things language agnostic in their designs, which in my opinion is kind of a flaw, because it means that it's, yes, you can transfer that knowledge from one language to another pretty easily. If you know reactive programming, you can do it in any language, but it means that you're passing on a lot of the strengths of each language that you're in order to make things as same as possible between every language that you're working in. Effect, in my mind, is taking kind of a very different approach, even though it's based on the Zio, which is the Scala equivalent. It was the inspiration for Effect. My understanding is that now Effect's design is pretty detached from needing to keep parity with Zio, right? Effect is basically about TypeScript and getting really good at TypeScript, making TypeScript the best it can be. And there is no, as far as I know, I don't know, I can't speak for the core team, but as far as I know, there's no attempt at saying, well, what if we make Effect for Java or Swift or Kotlin? It's not about that. It's just about what is TypeScript good at and how can we be really good at that. So that's a really big point, I think, because with RxJS in TypeScript, it never felt like they really got how to make a type-safe reactive stream application really work. The types kind of sort of worked. As far as I recall, there wasn't really a great story around requirements management or even really error handling the way there is with Effect. And so it lacked a lot of the potential. It failed to take advantage of a lot of the potential that TypeScript has to offer in the way that Effect does. Does that answer your question?
No, it does. And it reflects also my perspective. In fact, I've been using Reactive Cocoa back in the days, and I believe that was early on in Swift. And it was quite pleasant to use, but it was very deliberate for the purposes of streams. And there was sort of like a peak moment where I got really into it. But then I felt like a lot of like impedance mismatch, where everything wanted to be modeled as a stream, but not everything is a stream. Some things are just like a one-off thing, and you just do an HTTP request and you get it back. And sure, that might fail, and like eventually you're just interested in one value, but you kind of model like your tree tries, etc., as a stream, etc. So this was like my first exposure really to this mindset, but it felt like the gravity was too hard on like this very specific primitive. And this is where I would rather like create more distance between effect and RxJS, because effect is not trying to like tell you, hey, everything is a stream. No, effect gives you a stream abstraction that lets you use the stream abstraction when you have a stream. For example, when you use a WebSocket or when you use something else, maybe you want to read a file and like use streams through the bytes, etc. This is where streams are a great use case. But if you just want to do like a one-off thing that happens to be asynchronous, then you don't need to be forced. This is the stream mindset. But this is where effect gives you different primitives. And I think this is kind of a huge leap beyond what RxJS gives you. And I think this was always like the big caveat for RxJS, that not everyone buys into the everything is a stream mindset. And this is where effect is much more applicable to any sort of circumstance where a programming language is applicable to. So, but yeah, very interesting to hear your perspective on this. You've been mentioning Cortex now a few times. So before we dive into how it's built specifically and how it leverages effect, can you motivate what Cortex is and what role it plays within MasterClass?
Right. Yes. So MasterClass has been developing over the last year plus our own in-house voice AI chat that is got kind of a MasterClass twist to it, and that you're not talking with fictional invented characters or anonymous, service bots, but or got authorization from many of our instructors who are working closely with us to essentially clone them into an AI persona. This includes like an LLM that is trained on their ideas, their writings, their public speaking. And it also includes a voice clone of them. And in some cases also, we have some chefs like Gordon Ramsay is being released soon, and we have a lot of his recipes that are included, and he can walk you through making one of these recipes. So it's a really interesting interactive way that I think enables MasterClass instructors to make themselves really available to a much broader audience than they would be able to on their own as individuals. And so this has also presented, an enormous technical challenge, because I think when you are talking to an anonymous AI, well, you might be a little bit more forgiving. You know that it's a bot that you're speaking to on some level. But with these real people who are very invested in the integrity of their image and their public persona, the bar is much higher, I think, in terms of really representing that. And this is also like, if you sign up and you try to interact with Gordon Ramsay, well, if you're a fan, how many times have you seen him on TV? You can watch the MasterClass courses. There's also like more than an hour of content. You know what he sounds like. You know how he speaks. You know what he's passionate about, what he doesn't like. This personality is something that you've probably learned already. And now we have to put that into an AI agent or an AI bot that you can talk to. And so I feel like the verisimilitude has to really be there. And so that's been really challenging, just to kind of get through the uncanny valley stage of that. And so this is the background of what we're building. If you want to try it out, you can go to oncall.masterclass.com, all one word, oncall, oncall.masterclass.com, and you can sign up and try it out. So this is the general product that we're building. And we have a whole LLM team, machine learning team that is working on getting the voice models and the LLM models really trained up to represent each instructor. And what I got brought on to do was essentially to create an orchestration layer, because we have several different components in the pipeline in order to build this experience. First, we have a speech-to-text component where the end user's voice, the microphone stream, is sent to a speech-to-text service that then listens to the user's speech and derives transcripts from it of what they've said. And then at certain intervals, when we believe that the user's done speaking and is ready to hear what the AI has to say, which is not a trivial problem, by the way. We then send that transcript to the LLM to generate a response, and then the LLM generates a text response, and then we send that off to a text-to-speech service to generate the audio for that response in the instructor's voice, and then send that back to the user. So we have several different asynchronous services, the speech-to-text and the text-to-speech components of which are WebSockets, and then the LLM is a HTTP streaming connection, essentially wrapped in an async iterable in the JavaScript world. So this is, coordinating between these different elements. But as you can see, there's kind of a, step 1, step 2, step 3 to this process. What makes it kind of interesting is, as I mentioned, we don't know if the user is done talking yet. The user can kind of start talking again at any time. What we want to do is shut down anything the bot is doing at that point, because the user is supreme. The user derives the conversation. We don't want the bot talking over the user when the user is trying to say something. And so it's really crucial that we are very responsive to that and stop whatever's in progress downstream, whether it's at the LLM stage or the text-to-speech stage. And so this is essentially what Cortex is doing. Cortex is a Node.js application that is connected to by WebSockets from our 2 clients that we have, web and iOS clients, that connect to Cortex over WebSocket. And Cortex, in turn, provides the WebSocket interface that abstracts these multiple services and receives the microphone audio stream from the user and emits back bot audio events. So from the client's perspective, the contract is simply send the user's microphone audio to Cortex and receive back the bot audio. And then the clients have to actually play it through the speakers. And that's kind of the whole contract. There's a couple of other details in terms of, if a tool call happens, or if the state change happens or something like that. But that's the main gist of what that WebSocket contract to Cortex looks like. Under the hood, however, Cortex has to orchestrate the various services that I talked about, execute tool calls, and do a whole bunch of other, state management under the hood. And so that's what we built with Effect. It's 100%. 100%, but it's pretty much every piece of it is built in Effect or using Effect in some way.
That's awesome. So you've mentioned that initially when you got into this project, you got a first proof of concept, and where it really exposed you to all of the complexity that for solving this actual product, to implement this actual product, this complexity need to be tamed. Did you work off that initial proof of concept, or did you rather roll something from scratch? And how did you go about that?
Okay, that's an interesting question, because I'm always trying to figure out how to re-architect a piece of software. It's something you don't want to have to do very often. Also, I don't know actually if it's me or just the stage of career I'm at and the kind of problems that I get brought in to help with, but I often find myself looking at a piece of software that is in need of re-architecting. I think it's largely because I was specifically asked to re-architect it in this situation. But the proof of concept was interesting because, it was built by our project lead on Call, who is now our VP of architecture, who's just a brilliant person who has no experience really with JavaScript or TypeScript, and asked ChatGPT to help. I think it was ChatGPT to help with building it, and essentially just pieced it all together from ChatGPT prompts. There were a couple of things that came out of that were, for example, a library that is like a private library that isn't really maintained. There wasn't really a top-level architecture. You had individual pieces that were kind of worked in isolation, but then the glue between them became really convoluted and hard to follow. So that kind of became a problem, but it worked. Ultimately, this proof of concept kind of worked for a demo. It didn't handle interruptions very well. It didn't have great latency, but it was impressive. The reality
of most production grade systems, or actually, let me take that back, probably not production grade, but applications, JavaScript applications that are running in production are probably in that sort of state where it's working well enough on the happy path, but all of like those higher level requirements that really make a end user experience superb, that you can interrupt an AI model when it's talking to you, or that is more resilient to errors, etc. This is where you need to go beyond that convoluted, everything kind of pieced together. And I think this is like a perfect point to start with, like applying effect to go beyond that sort of like messy state.
Yeah, this is why I wanted to tame the asynchronous behaviors in Cortex, and I was looking for a package that would help me do that. And this is when I found Effect. And then at that point, like I said, I had seen RxJS, and I had good experiences at first building RxJS, but like kind of one of the common complaints is that well, now, like you said, everything has to be a stream now. You have to model everything in this way, and it really completely changes how you architect your software. And you need a lot of buy-in from your team if you're going to start doing this, because now everybody has to learn this. They can't just sit down and, start coding on whatever part, feature they're trying to do. They have to first learn this framework, and that can be a big ask for folks. And so that's something that I wanted to be conscientious about. However, when I started looking into Effect, I started seeing, well, this has a lot of promise and potential if you use it in the right way. And what I mean by that is like, you don't have to necessarily go from 0% to 100% overnight. You don't have to completely redesign the entire application to take advantage of some of the benefits that Effect has to offer. That's kind of how I started, was incrementally adopting Effect in parts of the code base. And this was really what enabled it to work at all. If I had to say, hold on, I need to take this for a month and just completely build it from scratch, and nothing's going to work, and I can't deliver any new features until I'm done, that was not going to fly. I was in a position where I did not have to ask for permission to go live in a cave for a month or however long it was going to take. I always avoid being in that situation. I don't think that's a good place for us to be in as software engineers. We need to be shipping every day, shipping features, shipping bug fixes, shipping products constantly. And we never have the luxury to just say, well, hold on, I'm just going to spend a month not shipping, to do this technical thing that I can't really explain why I have to do this, right? Nobody likes that. So fortunately, Effect is not a framework that is like that. That's not what was asked of us to adopt Effect. Instead, it was, you can start plugging in Effect judiciously here and there. And I started at the top level of the application, around the WebSocket connection layer, around the HTTP layer, and the application runtime. And that allowed us to kind of have a top level of error handling that immediately provided benefits for recovery and so on. But we didn't stop there. That was just the first step. We started kind of rebuilding different parts of the application. Some of them were isolated behind a run promise or a stream that was, emitting events into an event emitter. But it allowed us to kind of rebuild isolated parts of the application on their own, where selectively where we thought they had the most value to be converted into Effect, and often driven by product requirements. So when I wanted to implement interruptions, that was the reason to now rebuild the speech-to-text component in Effect, because it was going to be a lot more work to do that if I was going to have to do it the old way. It was it wasn't rebuild the whole thing in Effect, the entire application, or just keep working the old way. It was really for each isolated piece. It was do I want to add more spaghetti to this application and this component? Or can I just rebuild this piece in Effect and make it much more expressive and elegant while building the feature that I'm being asked to build? So it was much less of a refactoring process and more of a incrementally adopting it while also building and delivering features.
I love that. And I think you've hit on a couple of really nice points here. One is that effect, even though you get a lot of benefits, once you have kind of effectified more and more of your application, you're going to find that you can delete a lot of code. Everything just fits nicely together. In the same way, if you incrementally adopt React, let's say we're just in this transition of like transitioning a larger code base from jQuery, something else, to React. You don't need to do that in one like long night, but you can do that step by step. And once you've reached a point where everything is in React, then you can delete a whole bunch of like glue code, a whole bunch of like things that bridge from the old way to the new way. But it is also totally fine that you go through this like transitionary phase. But the other thing that you've mentioned that I think is like a super great insight, which is like, how do you prioritize what to refactor with effect when, or when to rethink something and apply effect? And this is so elegant that you can like go top down from like, hey, what is the thing that we want to improve for users? What is like the business outcome that we want to affect here? And then like looking at those, Effect typically has something in store for that. If you want to improve performance, if you want to improve reliability, resilience, error handling, whatever it might be, Effect typically has something in store for that. And then you can prioritize what to work on depending on your end user needs. And hearing here about the speech to text aspect and applying Effect for that, that sounds super interesting. So I want to hear a little bit more, like zooming into from macro into a bit more micro into this component. Can you give a rough overview of like how that thing was built before? What you diagnosed the biggest kind of like things to improve were, and which primitives of Effect did you use to ultimately implement it?
Well, actually, what I prefer to do is zoom in on the text-to-speech component, which is...
Sorry, I remembered that wrong, but yes.
No, it's okay. You remembered it right. It was I said speech-to-text earlier, but I feel like the text-to-speech component, this is the component that I also talked about in my Effect Days talk and did a deep dive on. I feel like the text-to-speech component was kind of like a real unlock, really an aha moment of like, wow, this is what Effect can do in terms of like saving a lot of complexity, from your code base. As I mentioned, this is a component where like it's a WebSocket and we stream LLM thoughts to it. So an LLM response, as you might be familiar, it sends, what are called chunks in a chat completion response. And the chunks are usually a token or two tokens, and they're not complete words a lot of the time. So then we're like accumulating the chunks into basically what we call coherent thoughts. And those coherent thoughts can then be sent to the text-to-speech component to generate the bot audio. However, if there's an interruption, we need to shut down the LLM, and we also need to shut down the text-to-speech component so that we don't continue to generate more thoughts based on the previous thing that the user said before they continued talking, and now we want to start over and respond to the most recent thing that that user has said. So the text-to-speech component now, it's a WebSocket connection. When you send it a coherent thought, that connection will then respond asynchronously with one or more different events that you might get. And we're basically just streaming those up to the client. But when there's an interruption, we need to actually shut down the WebSocket connection, close the connection abruptly so we don't get any more messages from it, and then reopen it. And then in that period of time, and it's not usually very long, it can just be like 100 milliseconds or 200 milliseconds where we're waiting for that WebSocket connection to open. We've created a connection, but we've not yet received the open event from the connection. And it's in that time that we were often getting the LLM was trying to send messages to it, but it was erroring because we were sending WebSocket messages out to a WebSocket that was not yet open. So we had to now queue those messages to wait for the open event from the WebSocket connections and then flush the queue when it was open. So as you can imagine, this created some code complexity in the pre-effect implementation, and it was something that Effect turned out to be actually very good at, because these are the kinds of things that Effect has out of the box. In fact, we were able to replace the WebSocket handling code with the WebSocket utility from Effect's platform APIs. And that has kind of a magical property to it that you don't really ever have to think about when the WebSocket is closing and opening, and you don't have to wait for an open event. What it essentially gives you is what is called in Effect a channel. And this became a primitive that I became curious about. It's something that I wish was a little bit more first class in the Effect world. It's certainly used behind the scenes in a lot of things like Stream and other APIs in the Effect world, but this is what you get essentially when you create a WebSocket connection using the Effect platform API. But then if you use the Effect stream operator pipe through channel, you now have a duplex stream, which is one where you can start listening to other streams, and then instead of doing like a run for each or run collect or whatever you're doing, and that you typically do with a stream, you now are piping the events or the items in that stream out through the channel, through the WebSocket connection. And then downstream from that pipe through channel, you are getting incoming events that are coming from that WebSocket connection that you can then emit further on down your application. So this is great, but this is also, what this is also doing is this is abstracting the WebSocket lifecycle into the stream lifecycle. So if you emit an error upstream, it will close the WebSocket for you. And then if you have a stream.retry, it will reopen the WebSocket for you in the event of an error. And because the streams are pull-based, you don't have to rely on queuing explicitly. You aren't going to miss any of your events. When the stream is reopened, it will start pulling those events and behaving as expected. So this really allowed us to abstract all of this sort of tangled, like we had, I think, a promise that was a reference to a promise that was kept around and was awaited in different places. And then it was a mess before. And now we had a single stream that was just a linear stream that where you had the stuff going in the top and the stuff coming from the stream coming out the bottom. And it became very easy to reason about what was happening. And you didn't really even have to think about the stream lifecycle at all. It was just emit an error when you want it to close and then just retry. The WebSocket connection is now handled by the stream lifecycle. So you can use the stream retry. The stream will be shut down when the scope of the stream ends, and the WebSocket will automatically close. We also have a flush event that we send out to the text-to-speech service, which essentially says, we're done sending you new speech for now, so send us everything you got. And the peculiarity of this particular service is that they will then accept your flush event, and they will promptly close the stream on you. That's not really what we wanted, but I don't know. They designed it this way, and I don't really have leverage to get them to redesign their entire API. I just have to work with what we have, right? This is a lot of application development. You don't have the liberty to redesign every API that you're working with. You have to abstract it in some way. And so this is what we're having to do here. But the Effect stream primitives make it really easy.
That sounds brilliant so far. What is so nice about this is that it is very clear and very intuitive from a user perspective what the system should do. And as users, we're all familiar with when this goes wrong and how frustrating it is. If I'm talking to the AI goes off in a wrong direction that I don't want, and I want to interrupt it, and it doesn't act on this interruption, need to listen to it for another 20 seconds until I finally need to repeat what I've just said. And all of those things, they need to be handled. And all of that is a lot of complexity. And if you leave that complexity unchecked, like you said it was a mess. And I think that nicely reflects the majority of JavaScript applications that are out there, or TypeScript applications. And I think it's really like this like fine line to walk where you capture all of like the existential complexity that your use case requires and shaving off like all the accidental complexity and isolating this nicely. And even to a degree where you say like, okay, those services that you need to call, they're not in the ideal shape that you would like it to be, but then you can just like wrap it and create your own world that you're happy in and where you can model your application in a nice way. Yeah, I'm very happy to hear that effect streams and the various primitives that you've been using the WebSocket abstraction that Effect gives you, and I suppose also queues, etc., that all of this has been so nicely fitting together to model your use case. So going a little bit beyond streams, which other aspects of Effect have you been using, or which other kind of superpowers have you been getting out of Effect that have played a meaningful role in the application?
Well, the error handling has been huge, honestly. We modeled all of our possible errors. We have, I think, maybe up to 30 or so errors that the system can emit that are domain-specific tagged errors. And those are decorated with a specific error code and an error source, because one of the things that will often happen, or that was happening originally, I think, was, oh, we got an error, the connection went down. Well, we got an error and like something weird happened and I don't know why, and now I'm in a weird state. Oh, we got an error and the whole service just crashed or something like this, right? And even if you can just wrap everything in a try-catch, best case scenario, you have some unrecoverable error, your connection goes down, and you don't know why. You just know, oops, bye, and then all of a sudden. And so it's frustrating for the user, and it's also frustrating for the rest of the team when they're trying to diagnose what's going on, which we spend a lot of time doing in our development workflow internally. And, I'm a big fan of passing the buck. So I don't like things to be my fault. And I think we're all like in that domain. I say this to joke. Actually, I'm fine with taking responsibility if it's my fault. But I would rather things not go wrong because of the decisions that I made. A lot of times early on, it was like, oh, Cortex is down. Oh, Cortex emitted an error that I don't understand. And, fair enough, from a client's perspective or from a test engineer's perspective, that's what it seems like. But that doesn't really give you enough information to troubleshoot. Because most of the time, it's not, Cortex is just a hub. Cortex is just passing events from one service to another. It's not Cortex really as the source of the errors. Instead, what we see a lot of the time is, oh, one of our backend services went down. Oh, a backend service emitted something that we didn't expect. Oh, it's being slow or something like this. And now we're able to create targeted pinpoint errors whenever a specific thing goes wrong somewhere in the system. And then those propagate up to our top level error handling. And so if we have something that's unrecoverable that happens, we can now close the connection like before, but now we can send up detailed information that allows our people to diagnose what's the problem. So it's not Cortex. It's like, oh, our speech to text service crashed or is out of memory or something. And so now we aren't able to create calls until we fix that piece of infrastructure. So that gives us a lot more information that kind of actually saves a lot of time debugging the system. It points you directly to where the source of the problem is instead of making you go on a debugging hunt. So that has been huge for us. The error handling has been extremely valuable. There are a lot of other errors that are recoverable, but we want to log and report them. So the whole error handling story, in effect, is fantastic. Just surfacing when things can go wrong and forcing you to deal with it. It has also meant, interestingly, I feel like that, within Cortex, not every function is an effect. Not every single line of code is a yield star. There's a fair amount of just plain old data manipulation that is happening throughout the code. It's data manipulation using functions that are synchronous and aren't going to throw. right? You can have very high confidence that, if you're trying to get an index of a thing from a string, or whatever, it's not going to throw. You can do like a lot of just kind of conventional programming in areas that are kind of safe and sandboxed. And it doesn't mean that every single calculation needs to be done in an effect. It just gives you a safe place to do that kind of work without having to worry, if this throws, or if this does something asynchronous and I, don't handle it, don't await it or whatever. Usually those kinds of cases they get a lot of attention because we have to think about them so much, but that's not usually the most of the work that we're doing. Ideally, right? We're thinking about like purely functional transformations of data from one state into another, taking the input from some kind of asynchronous effect and sending it out to some asynchronous effect. But like the actual program, the business logic is usually something that is like pretty, step by step, just logic. Is usually when we're not interfacing with an external, service or some kind of side effect, then we can just write code like normal. We don't have to model everything as a stream just to add up some numbers or something.
Right. And I think the super plain way how you put it, just write code like normal. I think this is kind of in a nutshell, the difference between Effect and RxJS, where in RxJS, you need to do everything as a stream. And in Effect, you can write code like normal. And another aspect of writing code like normal is treating errors as values. We're all super used to just passing around and manipulating data. And somehow we're kind of brainwashed into thinking, no, errors need to be like, we need something, we're almost like paralyzed about like, how should we deal with errors? But if we're just treating errors as values as well, errors as data, and passing them around, and Effect just makes that easy by giving us a separate channel to deal with that error data. And then, like you say, like you don't want to, you'd like to pass it along, then it's just data that you pass along. So I think that's just like code like it's normal. I think that is like one of Effect's superpowers. And closely related to errors is like having visibility into when errors happen, when something doesn't go as expected. So, and I think if I remember correctly, the telemetry part, the observability part, has also been a key aspect of building Cortex and operating it. So maybe you can speak a little bit more to how you do observability and telemetry usually within MasterClass, particularly within JavaScript applications, and how Effect has helped you to maybe improve that even further.
Right, yeah. So I sort of have to admit that we don't have an excellent story for the most part, or before Cortex didn't have an excellent story about observability at MasterClass in the JavaScript world. And, we have a number of services. We have, we have Raygun, we have New Relic, and we have CoreLogix. We get our, logs to. We send our logs to. And so we have a bunch of observability services for things like video. We have a dedicated video monitoring service that we integrate, and a few high-value business applications like that. We want to keep an eye on, error rates for people visiting our homepage, or things that are really indicate business traffic. Business is being impacted by some technical problem. However, usually that amounts to like something that's easily reproducible and easily fixable. Usually, and there's either some infrastructure that needs to be restarted or code change that needs to be rolled back or something like that. Cortex really represents a new level of complexity when it comes to understanding what's going on internally. And I think that a big reason for that is that it is not one-shot HTTP server type of application, but is instead, a stream of streams, and is handling all of these asynchronous events that are passing through it. It's not directly doing much of any work. It's just literally in between all these services, handing events from one service to another. So as I mentioned before, when things go wrong, they're mostly not going wrong in Cortex. And likewise with observability, where the system is spending time doing work, it's mostly not spending time inside of Cortex doing that work. It's Cortex is instead waiting for events from other services. And so what we're interested in measuring is not really the conventional, I think, telemetry story when it comes to building tracing and spans. I think this is a story that is also baked into the default effect telemetry story, right? When you have a effect.with span with a name, and you wrap that around an effect, well, that's great. That ensures that span or that effect, the time that it executes, is going to be represented by a span in your trace. And for most like one-shot type of actions that you might perform, that works great, which is most of the time. If you're doing actual work within an effect, within a one-shot effect, then that is the conventional way that you do telemetry. We're not really doing that at all in our telemetry implementation in Cortex. Instead, we're interested in measuring time between events that are coming from outside services. Cortex is the only place where we can really gather this information because it's the hub, but Cortex isn't sitting around. We don't have like an effect that is sleeping until it gets a certain notification from or an event from another stream. It wouldn't make any sense to build the application that way. And so it doesn't really make a lot of sense to build our telemetry that way. I suppose what we're doing with open-telemetry is a little unconventional in that a span doesn't represent Cortex doing that work. Instead, it represents like the LLM is working or the text-to-speech service is working, and we're just waiting for that. But it's measured from Cortex, not from these other services. But because it is really all streams, what we have to go on isn't an effect that we're measuring. It is literally the time between two events in those streams that we're measuring. And so we really had to roll a lot of our own telemetry handling. But, we were going to have to do this anyway, ultimately, because when you have, let's say we're not using effect, we're using the original approach, the non-effect approach that is event emitters everywhere, WebSocket event handlers and so forth. You get a transcription from the speech-to-text service, and you want to start the span of time that it takes, that you're measuring that it takes to generate a response to that transcription. Well, you can have a central hub where like maybe you're collecting all of these events, but you're starting that span in one event handler, and then you're ending it in a different event handler for a different service. And so you need a place where you're holding on to those references. Might be a centralized location that is listening to all of these events, but then it becomes kind of tangled up because you're having to keep these references around and keep them alive from one event handler to a completely different event handler. And this is an area where, we had to roll some of our own code in Effect to do it this way. But I feel like Effect kind of made it easier to do it this way anyway, allowing us to have a kind of a connection level, long-lived reference to these spans, and then just manipulate spans in what is essentially a stream.tap, where we are listening to all of the incoming events and then just starting and stopping them based on which events are occurring. It's not been perfect, honestly. It has been a little error prone sometimes, and we've had to it's go in and kind of tweak things when we have unexpected behaviors. It's an area that has provided immense value for us, however. It's given us a lot of insight into what people are experiencing, if people are experiencing really slow behaviors, slow responses, if people are experiencing the bot is talking over me or this sort of thing. If we have errors somewhere in the system, we can see exactly where and when it happened and in what service and in what part of that service's work it happened. And we're able to trace, what was the sequence of chunks that were emitted by the LLM. How long did it take for us to get that first chunk out of the LLM? Comparing the user message and the bot response, and if the user interrupted the bot, how much of the bot speech did the user hear? And so a lot of these questions that are really of interest to the business and also for us technically when it comes to how on-call is being used and how people are experiencing it are really answered by the telemetry that we've built using open-telemetry and Effect. But it's a very custom system that I don't know that it has its optimal form yet. And I also don't know that it is necessarily going to apply to everybody in the same way. I don't, this is, like I said, it's a very custom system that is built for our use case that will not apply in most conventional applications. But I think that's okay. There's always special cases.
This makes sense. And where open-telemetry or the previous technologies that is based on open census and open tracing, I believe, those were the two predecessor technologies that merged into open-telemetry. Where they're historically coming from is like from distributed tracing. And that is typically in a microservice kind of architecture where you have one service, request, response style, calling into another one, calling into another one. So I think where those systems or this technology shines, historically at least, is on a request response pattern where you just get that burn down charge that you know from like a performance profiler in a single threaded environment or a multi-threaded environment. Now we get it over like a network boundary. So this is where those shine. But going beyond that for different modalities, like for long running streams, or I've been also experimenting with using open-telemetry in a front-end setting where like a front-end session, you don't have that request response, but you have a front-end session. If you, for example, think about how you use social media, you might be doom scrolling for a very long time. So is your entire session, that's the trace that you have with possibly like thousands of spans? Or where do you make a cut basically? How do you design your trace and your spans? I think that is still something that we're figuring out as an industry. And it's been cool to hear about your usage of it. And I think this also speaks to the flexibility of Effect. Yes, they're like default patterns, make it really easy and kind of trivial to instrument your app out of the box. But if you want to instrument it in a way that's a little bit more specific to how you would like to give your trace meaning, that's possible as well. Maybe taking a step back here for folks who are curious about open-telemetry and generally see the value in observability, but maybe haven't taken that leap yet themselves instrumenting their app. Which sort of guidance would you offer to people? What to focus on, maybe what to initially leave out of the picture just to get going?
Oh, that's a really good question. I feel like the answers are going to be really specific to your use case. And in the case of an application like Cortex, extremely custom. And we have spent a lot of time refining and iterating on our telemetry implementation. But most applications probably don't need that. Honestly, I think, especially in the JavaScript world, there's both browser and node-based auto instrumentations that are available that do a lot out of the box. So I feel like a lot of what I would want to start with are on the ends of the application when your code is calling out to another service or when you receive events from the user, because that kind of determines the shape of that user session or that interaction that you might be interested in measuring. And then it will identify kind of hotspots of like, oh, the user waited a long time for this response or whatever. What's up with that? And then you can start to drill further. And then the other thing that I think is really super valuable is distributed tracing, where you are propagating a trace across service boundaries. And sometimes this is just, you're instrumenting in your browser application or in your iOS application, you're making calls out to your API service and you want to see what's going on in the API service as well during that time period. You're propagating the trace from your client to your server so that when you see them all together, you can kind of piece together, oh, the client called out to the server, and then the server made these database calls, and you can see that all in one distributed trace. That's really super valuable. So just focusing on the ends, with the either incoming events or outgoing service calls, and then making sure you have your distributed trace propagation set up correctly. Those would be the top things I would recommend.
Right, I agree. And I think the benefits of having a good observability story for your application and for your system is so manifold. Like, it helps you with correctness to kind of understand like, like something is not going well, that you're not just like completely in the dark and looking for the needle in the haystack, but that you actually have a great foundation to figure out what went wrong. That is I think the foundation where people start leaning on observability beyond just console log, but then also like doesn't just help you with making things correct or diagnosing when something was not correct, but also making it faster. Like otherwise you might just know like, okay, that API request has taken 2 seconds, but why? And sometimes there's like really counterintuitive situations. It's very simple and very easy to realize, oh, this is why it's so slow. And also, speaking of AI, this will like be a perfect foundation to give an AI even more context what is going wrong, and let the AI iterate further and help you make your app more reliable and more performant.
One of the frontiers that we're going to be exploring, I think, now that we've cracked the seal on observability, is integrating it with our existing, data analytics or our end user analytics that we are already collecting. At MasterClass, a really good, robust data team that is, while respecting like anonymity and user privacy, is still really invested in understanding the user journey. What are people doing? Why are they there? What is enticing them? What's driving them away? These sorts of sort of questions that are really foundational to understanding the best way that we can deliver value to our users. Integrating this with the sort of open-telemetry will give us even more insights of like, oh, did a user try to load a page, but then they bounced because it took too long to load, and things like this, that they'll give us an integration level between the sort of end user metrics that we've been using and also the technical implementations behind the scenes that are underpinning that user experience. I'm really looking forward to being able to explore that further, and I feel like it has tremendous potential to offer value.
That sounds awesome. So speaking of a bit more forward-looking perspectives, I'm curious, now that you've been part of the Effect community, I think at this point, way beyond a year already, and super impressive what you've been able to build with Effect in that short period of time. What are the things that you're looking forward most to when it comes to the Effect ecosystem?
I'm really looking forward to seeing Effect 4.0 come out. That looks awesome. A lot of the improvements they've made to the bundle size and to the implementation complexity look really promising. And, I really admire how responsive the Effect team has been to the community, to the needs of the community, and really listening to feedback, incorporating it, iterating. That's really, I think, been vital to any platform like this getting any traction. It's a very ambitious platform. It just has to be said. The design of it to encapsulate so much information about what's going on at an atomic level in your application, but then extending that out into really building whole frameworks, the HTTP API, the schema, the tracing integration, the possibility, the database abstractions, the networking abstractions like WebSockets, file system, node runtime. There's React integrations. It's like really, you name it. There's just tons and tons and there's a whole bunch of stuff coming in down the pipeline. Cluster and AI integrations. The paradigm is really extensible, and it has proven itself really robust and able to handle all these different scenarios. But now making all of those things all work, that's an incredible challenge, and I hope something that that they succeed at. It's just so much. But I think that with this large and growing community, I think there will be people using every aspect of that. Probably not everybody is going to use every piece of the Effect ecosystem. I am not, certainly. And most people will only use a small sliver of it. And that's fine. That's all you really need to do. But when you have hundreds or thousands of engineers all building different kinds of applications with it, now you start to get a lot more signal on, for this specific use case, here's what I'm trying to do. Here's how I've approached it. And that information, feeding that information into the design of the platform is going to be tremendously valuable to making it more extensible. But anyway, like I'm really interested in the Effect 4.0 developments that I think have come out of this exact kind of feedback integration and iteration. And also, I'm really excited about things like I think there was at the Effect Days, there was a demo that I think Mattia did. Was it Mattia who did about the error reporting, and that was integrated into the editor when there's like type errors in Effect. Sometimes those can be cryptic, and it's nice to see that they're working on making those a lot more like human readable and friendly. It's nice to see the dev tools getting so much love. It's nice to see the documentation getting so much improvement, so often very thankless. Honestly, like more than any specific like technical feature of the API, I just love to see the developer experience getting some attention. And it makes things so much easier on everybody to start building really cool, ambitious things if, you get really good, clear, understandable errors at build time or in your editor. And if you have really good debugging tools that let you understand what's happening, if you have really good documentation that has use cases and examples of all kinds of different types of patterns that you might want to take advantage of, this is the sort of, I think, often unsexy work of building a framework like this that is so fundamental to people, like end users being able to get value out of it. And it seems like the Effect team is taking this seriously. And that, to me, more than almost anything, is what gives me excitement and hope about the future of this framework.
100%. I mean, I couldn't agree more. They're all super ambitious efforts on their own. And luckily, we have a small but super talented and absolutely brilliant core team of folks who are working on the various pieces. You've been mentioning the docs. We have Giulio working more or less full-time on the docs as well as on Effect Schema, which we could probably also fill an entire show on just talking about Effect Schema, which I think you're also using.
Oh, but yeah, we're using Effect Schema all over the place. I didn't even talk about that. Yeah.
Yeah. But then also the dev tools, I'm super excited that Mattia will be joining. Well, at the time of this recording, in a couple of days from now, but when the time comes and the recording airs, I think Mattia will have already started working full-time on the dev tools and other pieces and improving the developer experience. And then at the core of all of it, Effect 4.0 and what it will enable. That's really been the distillation of all the feedback that we've gathered over the last couple of years. And I think really tackles some of the most common points of feedback or frustration head on. And I think is really like a huge improvement over what's already really great and useful. So I'm fully on board with everything you've shared. And yeah, I think I can't thank you enough for sharing all of that. What you've been building with Cortex at MasterClass is really, really impressive. What you've been able to build in such a short period of time speaks to your experience, but also speaks to just like how capable the building blocks are. And like when like experience and ambition comes together with great materials, I think this is how we're going to get great experiences and great applications. So thank you so much for doing that work and sharing it. And thank you so much for coming on the show today.
Well, thank you so much for having me. And I just, I have to say that so far, I think the On-Call product has been a huge success, and Cortex has been a very crucial part of that. And I feel like it would not have been possible without the Effect ecosystem and also the support of the Effect core team and the community to helping us get there. I think that has played a fundamental role. So thank you. To you, Johannes, and thank you to the broader Effect team and the community for all of the support and assistance and enthusiasm and building this incredible framework. It has really been a game changer.
That is awesome to hear. Thank you so much.
Thank you.
Thank you for listening to the Cause and Effect podcast. If you've enjoyed this episode, please subscribe, leave a review, and share it with your friends. If you haven't done so already, you can join our Discord community. And if you have any questions, feedback, or suggestions about this episode or about Effect in general, don't hesitate to get in touch. See you in the next episode.